final two problems, which I called level 4, are problems when you have combinations of ions, and then you add a third ion that's going to cause them to precipitate. It will probably cause both of them to precipitate at some point, but we don't know what that point is, and the question is always which one is going to come first. So we look at 17.53 from the book. We've got two systems. We've got silver and the other one is lead. Right? And we're going to be adding these iodides. So it's important to make sure I've got the expression right, because for silver, the expression is concentration of silver times concentration of iodide. But for lead, it's concentration of lead times concentration of iodide squared. So I know the Ksp for both of them. So that's given to me here and here. And I get to plug in for the expression the known concentration of silver and whatever concentration of iodide is, we'll just call that X. And in this case, for silver, when X equals 4.15 times 10 to the minus 13 molar, that means when the concentration of iodide reaches that level, that's when I would see a precipitate. For lead, this X is still the concentration of iodide, but it's not the same concentration. For lead, when the concentration of iodide reaches 2.29 times 10 to the minus 3 molar, it will start to precipitate. So when I compare these two numbers right here, 4.15 times 10 to the minus 13 compared to 2.29 times 10 to the minus 3, there's a clear winner. That if I need to say which one will precipitate first, it's going to be the silver iodide. That's going to precipitate. It begins precipitating at the lower concentration. So that's what I have to do. Anytime I'm evaluating one of these is I have to determine what level the precipitate will start, and whoever's lowest, that's who's going to precipitate first. This means that inside the system, when you have that one beaker that contains both the silver and the lead ions, if you slowly add iodide, first thing that's going to happen is that only silver iodide will precipitate. And it will be the only thing that precipitates until you can get the iodide concentration all the way up to this level. So you could actually separate something based on its solubility.